Okay, so for the 5-1, again, we're going to be looking at lowest common denominator, which is why we're factoring for prior knowledge, and then we'll learn about excluded values and what they mean today. So for the concept slide, we have here a rational equation is an equation that involves at least one rational expression, meaning that the variable is in the denominator. And in order to be an equation, there has to be an equal sign. So examples I can see, that one has an equal sign, and then I have variables in the denominator. The second one, I have an equal sign, and I have variables in the denominator. So those are rational equations. The non-examples, I can see, even though I have x's in the denominator, there's no equal sign, which makes it not an equation. It's just a rational function, but not an equation. The second one, notice I have no variables in the denominator. So because I don't have variables in the denominator, it's not rational. Okay? Because remember, the whole point of rational equations, the variable in the denominator creates the asymptotes, because it creates the undefined values, and that's what makes it rational. Versus like the 2, 3, 5 in the denominator, I can't make any of that equal 0 any possible way. So then for that second equation on the non-examples, that's not going to be any asymptotes on that one, so it's not going to be rational. Okay? All right, so then we're going to learn about the LCD. Hopefully this term is familiar to you guys. The LCD is the lowest common denominator of a rational equation. Is basically the product of all factors that are shared between two or more of the denominators and any remaining factors of the denominators. And so we can see this example here. First, I need to take the denominators and I need to factor them. Notice the numerator stayed the same here. I didn't really change anything to the top numbers, but I do have to change the denominators. So I can see this x squared minus 36. That's a difference of 2 squares, so I can split into x plus 6, x minus 6. Then this 2x plus 12, they have a GCF of 2. They have a 2 in common, so I can take out the 2. And then I'm left with x plus 6. And this last one just has the x, you just bring it down, okay? So to find the LCD, I need to check to see what they have in common. So if I look at my denominators on this one here, what do they have in common? Well, I can see this first one has the x plus 6 and the second one has the x plus 6. So that's what they have in common, x plus 6. And I only write it one time in the denominator, okay? Everything else kind of just gets attached to it. So the monomials, like the terms that are by itself, like the 2 and the x, they get placed out front, and then anything else left over kind of just gets added at the end, okay? So for the LCD, I'm going to add a little note for you guys here. I'm going to put an asterisk. The common factors are only written once in the LCD. Lowest common denominator, okay? I only write it one time. So for example, I can see the x plus 6. Even though it showed up twice, the x plus 6, I only write it once in the LCD, okay? And then everything else just kind of gets attached to it at the end, okay? But the ones that are common, the common factors, we only write them once in the LCD. All right, so let's go ahead and look through some examples. I'm kind of just giving people some time I see people are copying that down. All right, so let's look at our first example. Go ahead and, well, actually, I think it's already there for you. You don't have to copy anything down. But the directions say to find the LCD of the equation. And so for the LCD, we're looking only at the denominators. For today, I'm not really going to care about the numerators right now. I'm kind of just going to ignore them, okay? This 8 and the 4, I don't really need them right now. I just need to look at the denominators. So first, I need to try to factor the denominators. Okay, but if I look at the denominator here, x minus 2, there's no GCF, there's no dots, I can't really do anything. This x, likewise, I can't really do anything. So this one is actually not factorable. So I can't really do anything. So all I do then for LCD is just check to see what they have in common. This is an x, that's an x minus 2. Those are not the same, they're not common. So I'm just going to basically just multiply them together, okay? So my LCD, I'm going to put the x out front and then the x minus 2. And that's it. I can't do anything else to that, okay? So that's my least common denominator. They don't really have anything in common, so you just multiply them together. If they don't have anything in common, just combine them together as one. And again, these are pretty straightforward. They just weren't factorable, so you just kind of combine them together. All right, so for this one, again, I can't really do anything to the x plus 5. This one, again, is not factorable. I can't do anything to the denominator. So all you do is just put them together. LCD, 3 is not the same as x plus 5. There's nothing in common, so you just multiply them together. The single one goes first. So the 3, the monomial, goes first, and then the binomial, x plus 5, just gets attached at the end. Okay? I'm pretty straightforward. That's it. That's all you do. All right, so I want you guys to go ahead and try this next one. All right, so for the LCD, what did you guys get for this one? What comes first? X, and then the binomial is x plus 3. And I can't really do anything. That's all I'm doing for now. It's just the LCD is x times x plus 3. Okay? Hang on to this here. We're going to come back to it because then we're going to learn about excluded values. So let's go back, I believe, to the front page. And we're going to do the next example. So this is at the bottom left-hand corner of your notes. You guys have to copy this fraction, 5 over x minus 1. Okay, again, you're copying this one. So, you're doing it on the front page, though. I know it shows up on the back also, but I want you to put it on the front page, bottom left-hand corner. All right, so again, you guys are copying the fraction 5 over x minus 1. Okay, so remember the first thing you want to do is factor the denominators. Okay, that's the first thing I do is factor the denominator. So if I look at this first one, x squared minus 2x, do I have a GCF here? I have an x GCF, so I can factor out an x. And when I factor out an x squared divided by x just gives me x minus 2x divided by x. The x is canceled, so that's just minus 2. So this denominator now kind of just goes away. I'm replacing that with x times x minus 2. In my second one, I have x minus 1. That one has no GCF, no dots, so I can't really do anything to this denominator. So for the LCD, then, I check to see if they have anything in common. This is an x. This one does not have a single x. This is x minus 2, that's x minus 1. They don't have anything in common, so basically just combine them into 3 separate things in the denominator. So LCD, I'm going to get x minus 2, x minus 1. I'm just taking all the denominators and putting it into 1. Okay? So I have the x minus 2, and the x minus 1. I'm just taking all the denominators and I'm combining them into 1 for the LCD. Okay, let's look at another example. Go ahead and copy this fraction out. This is 5 over 2x minus 6. Again, 5 over 2x minus 6. So I'm going to have to factor again. We need to factor. So I'm going to look at the first trinomial. This right here, x squared minus 5x plus 6. I'm going to figure out what it factors out to. That's a trinomial. So remember, trinomials, we do blank plus blank and blank times blank. So they have to add up to -5 and multiply to 6. And that's going to give me 2 new binomials here. So I want you guys to go ahead and work with your partner, try to figure out what these two are going to be. Figure out what the two numbers are, and that'll give you the 2 binomials. So my 2 binomials I have now are x minus 3, x minus 2. For the second one, if I look at the second one, 2x minus 6, notice I have a GCF here. What can I factor out of the second denominator? What do they have in common? A 2. So I have a GCF of 2 up front, and then 2x divided by 2 is just going to be x. The 2 is canceled. Minus 6 divided by 2 is going to give me 3. All right, then for the LCD, I'm checking for what they have in common. So if I look at the pink one and the blue one, do they have something in common? X minus 3, good. X minus 3 is in common, so I'm only going to write it one time, x minus 3, and then anything left over kind of just gets attached to it, okay? The 2, though, it's a single term, so you want to put that in the front. The 2 goes out front because it's a monomial. And then I have also this x minus 2 left over. So the x minus 2, I'm just going to add it to the end. So no, because it's the 2 is what the GCF was. Here, 2 is the GCF. I can't have a 3 there because 3 doesn't go into 2.
Yeah, because there's 2 there, and then there's 1 next to 2, and then isn't that 3? So,
So,
that's not how it works.
I'm not sure what you're telling me. Sorry. I confused your question. Because you said 3. What do you mean by 3?
Because, okay, you have on the left side, you have x minus 3, right?
This?
That's one of them, right? No,
Yeah.
The other side.
This one?
Yes, you have one of those, right? And
yeah.
Then on the other side, you have 2 of them. There's the 2 up front.
Oh, no, that doesn't mean 2. That doesn't mean... No. That doesn't mean 2x. If that was 2 of them, it would have a squared. But no, that's just the number 2. So then the 2 goes up front. All right, so then for LCD, again, I just put them all together into 1. So that is my final answer for LCD. Okay? So one more time, you factor the denominators. So this, it was a trinomial, so I do the blank plus blank, blank times blank. You get your 2 binomials. The other one here, I had a GCF, so just take out the GCF. See what they have in common. The common terms, you only write it once, and then anything else, kind of, you just attach it to the LCD, okay? So let's go ahead and have you guys practice this one. This goes back to the back page. This is the second practice problem on the back. Okay? Again, this is the second practice problem on the back. You guys are going to try this one. You need to factor the 2 denominators. And then see what they have in common for the LCD, and anything else just gets attached at the end. All right, so now that my denominators are factored for the LCD, I'm checking what do they have in common. So for LCD, what do we have in common? X plus 2. And nothing else. So x plus 2, I'm going to write it once. X plus 2. And then everything else, you kind of just attach it at the end. So I'm going to do this x minus 2 next. It doesn't really matter what you put, like what order you put them in, as long as you have all 3 of them. And then the x minus 4 at the end. But again, you can write them in any order. You could have written the x minus 4 first, then the x plus 2, x minus 2. You can do x plus 2, x minus 4, x minus 2. As long as you have all 3 of them, the order doesn't matter for the binomials. Okay? All right, so next we're going to learn about excluded values and extraneous solutions. So at the top of the second page, we have rational equations can have extraneous solutions. An extraneous solution is a solution that are excluded values of the expressions in the equation. So for a rational equation, if you remember, extraneous solutions are going to create 0 in the denominators. We don't want 0 in the denominator. That creates undefined terms. And so the undefined terms, we need to exclude them from the solution. Okay? So extraneous solutions are not included in the final solution set. So the 0 in the denominator creates undefined terms. Create undefined terms, resulting in asymptotes. That's how we get the asymptotes in the rational equations, is they're creating a 0 in the denominator. We don't want undefined terms. That's why the 0 in the denominator, anything that creates that, those are going to be excluded values. So I have to remove them from the final solution set. Okay? So we can see some examples here. Notice if I plug in 0 right here, 1/x, if I plug in 0, that's going to be extraneous. because that would give me 1 divided by 0. It would be undefined. So then it's an extraneous solution, and we would not include it in the final solution. Okay? And this next example is saying negative 1 and 2 would be extraneous. The reason why is if I plug in negative 1 here, negative 1 plus 1 would give me 0. And a 2 in this one, 2 minus 2 would give me a 0 as well. So I don't want a 0 in the denominator. So those two, negative 1 and 2, would be extraneous solutions. Okay? So if I look at an example, we actually already did this one. It's on the front page, but now we're adding to it. So on this one, go ahead and copy the second fraction. Or I mean, it's already there for you, my bad. But we already did the LCD portion for this one. The LCD, if you go back to the front page, what was our LCD here? We had a X out front, and then X minus 2,
and then X minus 1.
X minus 1. Thank you. So we already did that part, the LCD. So now for the excluded values, I need to figure out what values would be creating a 0 in the denominator. And so if you notice, these values right here came from the denominators. So basically, I already have this in the LCD. It's basically all of the denominator portions, okay? So I need to figure out when would these be 0, and those would be my excluded values, okay? So basically what I'm doing is making each one equal to 0. So this first part, I got x equals 0. And solve for x. X is by itself there, so I don't have to do anything. But for this next one, I have x minus 2 equals 0. I'm going to add a 2 to each side, and that'll give me x equals 2. Basically, I'm just switching the sign for those. X minus 2 is going to become a positive 2. And then for this last one, x minus 1 equals 0. I'm going to add 1. That'll give me x equals positive 1. So again, minus 1 is going to switch to positive 1. I'm just figuring out when would each piece equal 0. Now that I have my 3 values, those are my excluded values. So I'm going to put EV, but those mean excluded values. That's what that means, but I'm going to abbreviate it as EV. So my excluded values, x cannot equal 0, 2, or 1. Those would be creating a 0 in the denominator, so I have to exclude them from my final solution. So my excluded values, x cannot equal 0, 2, or 1. Those would be creating a 0 in the denominator. All right, so let's go ahead and look at the next example. Okay, we already did this one. Our fraction, go ahead and copy the fraction again. 5 over 2x minus 6. So we already did this one. What did we get for the LCD? If you look back at the front page, we had what, like a 2 in the front? And then I think it was x minus 3, x minus 2. Thank you. So I already did this one, the LCD. Now for the excluded values, you make each part equal to 0 and solve for x. So for this one, if I do 2 equals 0, does that make any sense there? Nope. 2 does not equal 0. So I'm not going to have excluded value in that one. For this one though, x minus 3, I'm just going to switch the sign. That's going to be x equals positive 3. And then for this one, x minus 2 equals 0. I'm just going to add 2. So basically, I'm just switching the sign. X is going to equal a positive 2. So the first part, the 2 by itself, does not create an excluded value. My excluded values are just going to be x cannot equal 3 or 2, because those would create a 0 in the denominator. All right. So back to the practice problem. You already have the LCD. LCD was x plus 3. So now go ahead and find the excluded values. X cannot equal what? All right, for this first one, that's an x. If I make it x equals 0, that means my excluded value is 0. And for this one, x plus 3, what did you get for the excluded value? Negative 3. Good. You just switch the sign. Okay? All right, last one really quick. You already did the LCD portion. What'd you get for LCD? X plus 2, x minus 2, x minus 4. Okay? So excluded values, you're just going to switch the sign. So x is not equal to what 3 values in this one? Negative 2, positive 2, and positive 4. Okay? You just switch the sign. Okay? All right. You guys have the homework assignment 5-1. It's hopefully not that difficult for you guys.